Hello friend, this is Rupesh and you're watching CPP Net video series on sorting algorithms, and in this algorithm we will see insertion sort, and these are the topics we will be covering, like introduction to the insertion sort, understanding with some diagrams and code understanding, and some theory part. Okay, and this is your array. This is the index of the array and these are the values. Okay, so let's start this sorting algorithm. Insertion sort algorithm is similar to the sorting technique what we use when we playing cards. Okay, so I will show you how to sort playing cards if you don't know, and we will try to simulate that same technique in programming. Okay, so generally what happens when you play cards, you will be having some cards. So let's suppose you are having these numbers, so let's write that 5, 2, 1, 3 and 4, and let's suppose you are holding these numbers in your right hand side. Okay, and this is your left hand. So initially you got numbers and you saw that okay, numbers are like this. Now you want to sort this, so what you will do, you will pick this and insert inside left hand side. So you will start from the beginning, like 5, so you will take 5 and insert directly, because this left hand side is empty totally right now. This is done, so this has gone from your right hand side to the left hand side. Now you will take this one and you will place in the ascending or descending order. Ascending means increasing order, like 1, 2, 5, 8, 9, 15 and all that. And descending means the reverse of this, like 20, 15, okay, like that, 10, 5, got it? So this is increasing order and this is decreasing order. So our insertion sort, what I'm talking about right now, is about ascending order. Okay, so we will pick 2 and place in ascending form. So 2 should come before 5, so this 2 is gone. Now we'll take 1. 1 will be picked from here and will go here. Okay, then this is gone. Then 3, pick, put in the correct position, this one, and same for 4. So take it and push inside here, so it will ultimately look like this: 1, 2, 3. After pushing 4 in between 3 and 5, it would look like this, and you have sorted it. Okay, so this is what technique we use when we sort playing cards. Okay, so the same technique is used to sort elements in the array. Okay, and I will show you how to use that. So before that, we can just simply remove this and this one. So now let's start the same technique what I explained here with programming. So let me write this here, like 5, 2, 1, 3 and 4. Now you want to sort it using programming. So we'll do the same thing. We will look at this element and we don't have anything to compare this inside left, okay, because left is empty right now. So we'll keep it here and we'll move forward. So we'll look this element and compare it with its left. So its left is this whole boundary. So 2 should come before 5. So what we will do, we will swap 5 here and 2 here. Okay, so ultimately it will look like this: 2, 5, 1, 3 and 4. And you remember when we were swapping, we were moving forward. So we took this into consideration and we swapped it, not swapped actually, we placed it to the right position inside left hand, which is this one, and now the boundary is this. So you will select 1 and you will take it and try to put it here in left hand side, okay, somewhere here. So this will look like this: 1, 2, 5, 3 and 4. Okay, now you was looking at this one, so you will increase the cursor, which is this one. So now you look for this one and your boundary is this. Okay, this is the cards in your left hand side and these are the cards lying in your right hand side. Okay, so you was looking for this 3. Now place this 3 in its correct position. So how you will place? Like this: 1, 2, 3, 5 and 4. Now you was at this position, so your cursor will move to the last one and your boundary will be this. So this is your left and this is your right. So you will pick this and place it here somewhere. Okay, so ultimately this would look like 1, 2, 3, 4 and 5. Stop here. I have not explained how this will work in programming. I have just given the overview how it will look in programming. Now let's see how it will look in actual array. You will be comparing this one and swap if this is not in perfect order. So 2, 5, 1, 3, 4. Now you will compare these two elements. Are they in perfect order? No. Then you will swap like 1, 5, 3 and 4. But you will not stop here. You will move further. You will compare this 1 with 2 also. Okay. So you will like compare backward also. See, you are moving forward with backward comparison. Okay. So now you will compare 1 with 2. Is it in correct order? No. Then you will swap that also. So it will look like 1, 2, 5, 3 and 4. Now your boundary has come to this place. Now you will compare this 3 with 5. Is it in correct order? No. Then what you will do? You will swap it 2 and 1. Now as I said, you will compare this 3 with 2, but this is already in perfect order because 2 is smaller than 3. Then you will stop here. You will not go further comparing. Okay? Because if you have encountered some element which is smaller than you, then it is obvious then left to that element value is also smaller than you. Okay, so you will stop here and move further. So move means before you was pointing at this location, now you will point at this location. So your boundary will look like this. Now you will compare 4 with 5. Is it in correct order? No. Then what you will do? You will swap it. So it will look like this: 1, 2, 3, 4 and 5. These two elements are swapped. Now what you will do? You will compare this 4 and 3. Okay, because I told you will have to go back, but this 3 is smaller than 4, so you will stop, and this 1 and 2 will always be smaller than 4. Okay, so you will stop here, and as you was checking the last element, you have come to the boundary now, and you will stop and see your element is already sorted 1, 2, 3, 4, 5. So this is what we do. We move further. You will move this way, but once you will start swapping, you will go back. Okay, the example is this 1. You compared 1 with 5 and you swapped it. It was looking like this, but you didn't stop here. You was comparing this 1 with 2 again. So see, you compared backwards, and until unless you reach to the place where you are hitting the boundary like this, or you hit some element which is smaller than you. In this case, this is the example. You started this 4 and swapped with 5. So this was the position. Now I told that we will be comparing 4 with 3, but 3 is smaller than 4, so you will stop. So there are two stopping criteria. Either you are hitting the boundaries or you are hitting some smaller number than you. Okay, so let's see how this program will look like in code. So this is how the code would look like. You are having this array here, 5, 2, 1, 3, 4. We are sending for insertion sort. So this is the function for insertion sort here. We'll be having two loops. This first loop will go forward. So let's write the elements so it will be easier for us to track it. 5, 2, 1, 3 and 4. So you remember we were going like this and selecting the each and every element. That will happen with this for loop. And we were coming back and iteratively checking each element in backward direction. That happens with this while loop. Okay, so we will see everything. So initially I is equal to 0, j will be 0 plus 1, so it will be 1. Okay, so I is at this location and j is at this location. Now you will compare that if array of j, so let's write the value of I and j. I is 0 and j is 1. So array of 1 is less than array of 0. Yes, it is true. And if this is true, just swap it. And swapping function is here. So we are just swapping the elements. Okay. Now j will get decremented by 1. So j from here, it will come here. Okay, so j will become 0. Now we will check, j is greater than 0. No, it is not. So this while loop will break and we will come to this loop again. I will get incremented by 1. So in second phase, I will become 0 and we will again come, I will become 1. Sorry for that. And we will come again inside that, j will become I plus 1. So j will be 2 now. Okay, and the same while loop will go. Array of 2 is less than array of 1. So let's update the elements also. Previously we called swap, so that would result like this: 2, 5, 1, 3 and 4. And I is here and j is here. So what we are checking, array of j, which is 2, is less than array of j minus 1. So yeah, this is less than this one. So what we will do, you will call swap function. So this will get swapped. So it would look like this: 2, 1, 5, 3, 4. Okay, j will get decremented by 1. So as I told, j was at this location, then j will come at this location, and I is also pointing at this location. Now what you will do, you will check j is greater than 0. Yes, it is greater than 0 because j has become 1 and 1 is always greater than 0. Now you will check array of j, which is 1 now. So you will be comparing this location with array of j minus 1. J minus 1 means 1 minus 1, 0. So you will compare this location with this location. And yes, again, this location is smaller than this location. So you will again call swap. So you will swap these two values and it would look like this. Okay, j will again get decremented by 1. So j will become 0 now. Okay, and we will go back, we'll check j is greater than 0. No. So we will come out from this loop and then this loop will run and we will increment I by 1. So before it was 1, now in next phase it will become 2 and j will become 3. Now we will be pointing at third location. So j is at this location and I is at this location. So as usual, j is greater than 0. Yes, it is. And we will check array of j, which is 3, less than array of 2. Yes, this is less than this one. We'll swap it. We'll call this swap function. We'll swap it. So this would look like this. We'll start from here now. And j will get decremented by 1. Don't forget that. That is the main key of checking backward. Okay, you are decrementing j. So as I told, j is at this location. Now j will come at this location and I is also at this location. Now what you will check, j is greater than 0. Yes, it is. And array of j, j means 2. Okay, it has become 2 after this minus minus. Then array of j, which is 2, is less than array of j minus 1. No, array of j is this one, array of j minus 1 is this one, but this is lesser than this one. So this condition is not true. So we will come out from while loop again. Okay, because while loop will terminate because this condition is false. You will go back here. I will get incremented by 1 again. So this phase is over. I will become 3 now. And as j will become I plus 1, so it will be 4. Okay. So let me write it again. It will be good. 5 and 4. So I is 3, which is this location, and j is 4, which is this location. Okay. Now again you will see j is greater than 0. Yes, it is greater than 0. It is 4. And array of j, which is 4, is less than array of j minus 1, which is 3. Yes, it is true. So we will again swap like this: 1, 2, 3, 4 and 5. And after swapping, we will decrement j. So j will come to this position and I was already at this position. Okay. Now you will again check j is greater than 0. Yes, because it has become 3 now, but 3 is greater than 0. Now array of 3 is less than array of 2. Let's check that. Array of 3 is this one, array of 2 is this one. No, it is not true. Array of 3 which is 4, not less than array of 2, which is 3. Okay, so we will not swap it. So if you are not going inside this, then while loop will break. So you will come out from while loop, you will go inside for loop. I will get incremented by 1 again. So I will become 4 now. As this will become 4, the condition is like this. I has become 4. 4 should be less than n minus 1. N was 5 because we have calculated n here. So this was 5. So 5 minus 1, 4. So 4 less than 4? No. So this loop is also terminated. You will go back from this function to your caller function, and we are just printing those values. Okay, so this was your whole process of your code compilation, running. So this was about coding part. Now let's look at the theory part. So as you can see here, I have written few points. So the first point is minimum complexity, time complexity. Second point is maximum time complexity and the stability of this algorithm, and is it a in-place sorting. So these questions can be asked in interviews or in exams. So this is really very important. So the minimum time complexity of this algorithm is order of n. Okay, and when it will be a minimum time complexity when array is already sorted. Okay, so if your input array is like 1, 2, 3, 4, 5, and then you want to sort it, it will take each and every element only once, and it will say that okay, this is sorted. So order of n. So the maximum time complexity is order of n square. So the worst case is n square, and when n square will hit, when your array elements are in descending order. Okay, like this. So if this is your array, you want to sort it in ascending order, then this will be n square. Okay, and is it a stable sort? Yes, it is a stable sort. And what is that stable sort? Let's suppose your array element is like this: 5, 2, 1, 2, 3. Okay, so you can see there are two elements. Okay, but this two element, the second element is its correct position. Okay, so if some sorting algorithm is stable, then this particular element will be at this position ultimately whenever you are done with your sorting. Okay, if you want, I can just show you the demonstration here. We know we compare this one with this one, and this is not perfect order, so you will be treating it like this. Okay, now you will compare this one with this one. So what will happen? 1 will come here, 5 will come here. So if 1 is here at this location, you will compare 1 with 2. So 2 is greater than 1. So then 2 will also come here. So ultimately it will look like 1, 2, 5, 2, 3. Okay. Now you will compare this 2 with 5. And yeah, this is greater than 2. So you will swap 2, 5, 3. And this 2 will come here and this one here. Now you will compare this 2 with this 2, and this is not smaller, so you will stop here. But notice this 2 is the exact this 2, not this one. Okay, this 2 is at this location, but this 2 is what we were discussing here. Okay, so you see that it is a stable sort because we mistakenly didn't swap it, even though both are 2, but this 2 is not going at this 2 and this 2 is not coming here. Okay, so that's called stability in sorting algorithms. Okay, and the fourth point is it an in-place sorting algorithm? So let's see what is in place. In place means you are not taking any extra memory or extra array to sort this. There are other sorting algorithms like merge sort and all, they take extra memory, so they are not in place sorting algorithms. And did you notice you was swapping in between array only? Okay, you was not taking any help of other arrays, okay, or any memory, extra memory. So that's why this sorting algorithm in place, and answer is yes. Okay, so I think I'm done here. Thanks for watching. I'll see you in the next video. Bye bye.